everyone, it's Jen from Old Tinkerer Studio. In this tutorial, we will be learning how to make basic materials and textures in Blender 2.83. So let's get on with the tutorial. Many times you hear the term material and the term texture used interchangeably. However, they are two separate things in the world of 3D. We will start with materials. Materials are used to control how a 3D object appears. Materials control the color and the reflectivity of a 3D object. Delete the cube and add a UV sphere. Right-click to bring up the Object Context menu and select Shade Smooth to smooth the mesh. Add a cylinder and move the cylinder along the x-axis with G and X so we can see both meshes. Left-click on the UV sphere to select it, and then go into the shading workspace. We can work either in the Material Properties panel or in the Shader Editor. To add a new material, click on the New button. Our material is named Material.001. It is always good practice to rename the materials using descriptive names. Click on the material name and change it to red and hit the Enter key. The default shader node in Blender 2.83 is the Principled BSDF shader. We will just be quickly looking at this shader. More advanced tutorials will be coming later. The base color is the diffuse color. Let's change the color to red so we can more easily see the changes we make to the UV sphere. The subsurface color is the subsurface scattering base color. The subsurface color simulates semi-translucent objects in which light rays enter, bounce around, and then exit in a different place. Like when you can see the veins in a person's ears in the bright sunlight. The subsurface mixes the diffuse or base color and the subsurface color. The subsurface radius averages the distance that light scatters below the surface. I won't go into detail about the subsurface options because that is a more detailed tutorial. Metallic blends between a diffuse material, which is 0, and a fully specular reflection, which is 1. Specular is the amount of specular reflection. Specular tint tints the facing specular reflection using the base color. Roughness adds roughness to the surface for the diffuse and specular reflection. If the roughness is set to 0, the material is completely reflective. If the roughness is set to 1, the material is highly rough with no reflective qualities. We will be skipping the anisotropic and the associated rotation for the moment since they only work in the Cycles render engine. Sheen is the amount of soft reflections near the edges. Sheen tint mixes white and the base color for the sheen reflection. Clear coat adds an extra white specular layer. Clear coat roughness is the roughness of the clear coat. IOR is the index of refractions, which describes how fast light travels through a material. Transmission mixes between fully opaque, which is 0, and 1, which is fully glass. We'll come back to the transmission roughness since it only works in cycles. Emission is the light emission from the surface. Alpha controls the transparency of the surface, where 1 is fully opaque. The normal, clear coat normal, and the tangent are inputs to control each of these properties. So let's switch to the Cycles render engine and look at the last 3 remaining options. The anisotropic is the amount of anisotropy for the specular reflection. The higher the value, the more elongated the highlights. The anisotropic rotation rotates the anisotropy with one going fully circular. And the transmission roughness controls the roughness of the transmitted light. We will now look at textures. Textures are simply 2D images used with a material. You must have a material to use a texture. Image textures are simple 2D images that are added to the materials of the 3D objects. Left-click on the cylinders to select it, add a material, and name it texture. Image textures can be simple diffuse textures which are used in low poly style modeling. They can also include such image textures as a bump map or specular map, which are used in realistic modeling. If you choose to use image textures, it is best to use a seamless texture that can easily be repeated across the model. Download an image texture. The link to the pebble texture is in the description. Make sure that you have the Node Wrangler add-on activated. To do this, go to Edit, Preferences, select Add-ons in the sidebar, and then search for Node Wrangler. Activate it by clicking the box to the left of the name. And make sure that you save your preferences. The menu is in the lower left corner. Make sure the principled shader node is active. And then click Ctrl T. This allows the Node Wrangler to set up the correct nodes. The texture coordinate is used for the coordinates of textures, and the UV output takes the coordinates from the active render UV map. The mapping node is used to transform an image or procedural texture. The image texture node is used to add an image file as a texture with the vector input referencing the UV map and the color output referencing the RGB color from the image. Open the texture you downloaded using the image texture node. Change the material properties on the principled shader as desired. Since I'm using pebbles, I'm going to change the roughness and the specular to 0.5 and 0 for the metallic. If we wish to use a more realistic image texture, we will need more than just a simple image. We will need to combine multiple image textures, which are also simply referred to as maps. There are multiple texture maps used in 3D. The diffuse or color map is the standard photo, which is the basis for all our textures. The albedo map is a diffuse texture with all the shadows and highlights removed, which allows for a more realistic texture. The ambient occlusion or AO map enhances the shadows and highlights of the diffuse texture, which allows for deeper shadows and brighter highlights. Please note in Blender, this map is not needed since the shadows and highlights are calculated in both the cycles and Eevee renderers. Bump maps use object lighting calculations to alter mesh surface bumps without additional polygons. The normal map works similarly to the bump map because it represents different axes of directions, which helps the 3D software to understand the shape of the texture. A displacement map is used to deform the 3D mesh, which allows for more mesh detail. It is used similarly to how a bump or normal map is used. The specular map tells the 3D software where the reflection should be. This type of map is only used on image textures. The roughness or gloss map controls the reflection sharpness. Gloss and roughness maps are simply the inverse of each other. Procedural textures are like vector graphics in 2D programs since they are defined mathematically. Procedural textures are more realistic and offer unlimited texture resolution, and they make texture mapping easier. Now download an image texture that has at least a diffuse, roughness or gloss, and normal or bump map. The link to the bricks texture I'm using is in the description. Now open the diffuse or color map you downloaded using the image texture node. If your texture image is too large or too small, you can use the scale option on the mapping node to scale the texture image larger. Larger numbers make the texture image smaller. Add a second image texture. Then move it below the original image texture node and open up the roughness or gloss image texture and change the color space to non-color data. Connect the color output from the roughness image texture to the roughness input of the principled shader. Duplicate the image texture node with Shift D and move it below the second image texture node. Then open up your displacement or height map and make sure that the color space is set to non-color data. Add a bump node, Shift A, Vector, Bump, and connect the displacement or height map color output to the height input of the bump node. Duplicate the image texture node and then move it below the third image texture node and open up your normal or bump map and make sure that your color space is non-color data. Add a normal map, Shift A, Vector, Normal Map. Connect the color output of the normal image texture node to the color input of the normal map node. Then connect the normal output of the normal map to the normal input of the bump node. This converts the image texture to an actual normal map. Then connect the bump node to the normal input of the principled shader and adjust the strength as needed. In the next Blender 2.83 Basics tutorial, we will be exploring lighting. If you're interested in learning more about 3D art and animation, don't forget to subscribe and turn on the notification bell. Thanks for watching. Have a good day.